Soalan nombor 13, dia bagi mass kat sini. Take note kena tukar dalam kg. Lepas tu dia bagi dia adalah vertical circle, meaning dia pusingan dia macam ni. Okay, dia turun, dia naik, turun, naik, turun, naik. Selepas tu dia bagi diameter of that circle. Therefore, awak kena cari radius dia. Okay, so next information dia bagi time for one revolution adalah 0.9 second, means information given to you is period. Okay, because period is time taken for one complete rotation. So one complete revolution is 0.9 second here. Okay. And then the question asks you to find tension at point A, point B, and point C here. So let's focus at point A first. They use 3L step that I mentioned to you in lecture. Okay, so at point A, sketch free body diagram first. Okay, so your free body diagram will be weight moving downwards and tension also downwards, because this is your string here, and then the tension is moving out from the object along the string. Therefore, this will be the direction. And then the direction of FC must be towards center. So this is your center, so this is your object. So FC is downwards towards the center. So direction is like this. Okay, walaupun saya lukis macam ni, tak bermaksudnya center dia dekat sini. Saya just nak indicating direction dia towards center from point A. So daripada point A macam ni. Tapi saya tak nak lukis dekat free body diagram tersebut. Saya just nak indicating direction dia like this. So FC is like so. There's no force on the X component, so you don't have to write down. But FC is on the Y component here, so FC is summation Fy. Okay, now what we're going to do next is do this part to find tension. Okay, so if you look at the direction for T and W, they are the same direction as FC, so just add them up like this. So, and then what you're doing right now, okay, is this part. Okay, you are adding all the forces acting on the Y component, and then this FC, you just you can write down FC or just expand the formula, which is mv squared over r. And then since it asks you for tension, why don't you rearrange the equation like this? Okay, so this I bring it here. Okay, or I can substitute mg here. So the problem is we don't have any information regarding the v. So you know that v equals to r omega. Okay, linear velocity, angular velocity, and this is the radius of the circle. So, and then you also know that omega equals to 2 pi over period. Okay, so that's how you get the value for v, which is 3.491 meter per second. Okay, once you get that, you just substitute this inside here, and then you will get the value for tension at point A, which is 2.91 Newton. Okay, so for point B, it's straightforward. Okay, so you have to sketch free body diagram. So this time, this is the string, so tension will be upwards. Okay, now the direction of FC, okay, this is your center, this is your object, so FC is this direction. But I don't want you to sketch the direction of label the direction of FC at the free body diagram. So the direction of FC is actually like this. Next, let's do this part. So fx and fy. However, don't have to do fx because there's no force on this x component. So fc will be on the y component. So next, what we're going to do now is actually this part. Okay, alright. At the y component, you have t and w. Okay. However, if you look at closely, tension has the same direction as FC, but W is on the opposite direction. So take note that when you're doing this part. Okay, so now it will be T tension plus with the negative W, which is equal to mv squared over r. Okay, Fc equals to mv squared over r. So if you want to find T, so just rearrange so that mv squared over r plus with the mg. Okay, this one I just bring it here. And then V you already calculate in the first part, which is equal to 3.491. Okay, so just plug in here, you will get the value for tension at point B equals to 6.83 Newton. Okay, so point C is here. So free body diagram, this is the weight, this is the tension. Okay, and then the direction of FC is that way. Okay, FC is that way. Okay, if you want to redraw the free body diagram, it will be like this, and then the FC is here. Okay, now if you look at the free body diagram, there's an angle 60 there. However, you cannot do X and Y component like this. Okay, because your direction of your FC need to be on X or Y component. Okay, FC ni tak boleh ada angle. FC ni mesti sama ada X atau Y. So tak bolehlah buat X and Y component like this. Okay, what you need to do is, okay, sengitkan axis anda. So I'm gonna let this be X component, this be my Y component. So barulah FC ni berada pada paksi X. Faham Saya ulang lagi sekali. FC mesti ada sama ada di X atau Y. Dia tak boleh ada angle. Ingat FC ni adalah resultant kan. So dia tak boleh ada angle. So saya pilih ini X, ini Y. So FC sekarang ada di component. Okay, so Fy saya yang 0. Okay, take note benda ini. Selepas itu, so awak nampak sekarang yang ada angle adalah weight sekarang ni. So kita nak tahulah macam mana kita nak cari, kita nak label weight angle ni. So jom kita tengok dekat dalam diagram ni ada angle 60. Okay, ni X komponen saya, ni Y komponen saya. So, dia ada banyak cara sebenarnya. So saya tunjuk satu cara di mana kita nak label 60 tu. Okay. So, katalah saya guna ni lah, nampak sikit. Okay. Ini, saya jadikan triangle. Ini triangle saya, right angle triangle. So, saya ada angle 60 dekat sini. So, saya nak lukis juga triangle yang sama, right angle. Okay, dia macam satu clone dekat sini juga. So, ni 90 degree. Therefore, saya mendapati ini pun akan jadi 60 degree juga. Okay, so kalau saya padam ini, okay, awak akan nampak inilah 60 degree tersebut. Nampak? Okay, ini salah satu cara untuk determine angle untuk free body diagram anda. So kalau saya nak label, so 60 degree sekarang adalah di sini. Okay, alright. So bila dah label kat sini, saya tahulah dekat sini akan jadi W cos 60. And this will be W sin 60. Okay. Lepas tu barulah kita buat next stepnya, which is this part. Kita nak cari tension kan. So Fx, katalah saya nak guna Fx equals to Fc. And then Fx saya ada dua benda. Okay. Saya guna colour ni sikit. Fx saya ini, so which I have tension and W cos 60. Okay, so I'm going to write that down. Okay, Fx T plus with a negative W cos 60 and then mv squared over r. Okay, and from this we can calculate tension. Okay, mv squared over r plus with mg cos 60, and you will get the answer of 5.85 Newton. Okay, so that's the value for tension at point C. Okay, so saya rasa yang point C ni yang kebanyakan masalah sebab dekat angle tadi tu. So I hope you understand at question 13 here. Thank you.